Okay, the following is a tutorial on drawing Lewis structures. Okay, so the first example that we're going to do is nitrogen trichloride. Okay, the first step is going to be to draw the skeleton structure. So when you look at the formula, typically the element that has the smallest subscript is going to be your central atom. Okay, in this case, that would be nitrogen. So we're going to have nitrogen surrounded by 3 chlorine atoms. Okay. So that is your skeleton structure. The skeleton structure just shows what atoms are going to be bonded together. Step 2 is to follow the octet rule. So the octet rule says that atoms will lose, gain, or share electrons so that they have 8 electrons around them. So they're going to pool all of their valence electrons so that every element has 8 electrons around it. Okay, the bond represents 2 electrons. So right now, this chlorine atom only has 2 electrons around it. So we're going to fill in the rest. 4, 6, 8. We have the same scenario for this chlorine atom. 4, 6, 8. 4, 6, 8. Okay, so 2, 4, 6, 8 electrons. So nitrogen currently only has 2, 4, 6 electrons. Okay, step 3 is to check the total valence electrons. So each one of these elements has a certain number of electrons in its outer shell, and those are going to be the ones that are available for bonding. So when we look at our periodic table, okay, we see that nitrogen contributes 5 valence electrons. Chlorine contributes 7. And there are 3 chlorine atoms in our structure. So we should have a total of 26 electrons in our structure. So we go through and check that. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So we do have 26 electrons in our structure, so this is the correct Lewis structure for nitrogen trichloride. Okay. Let's do O2, oxygen. So our first step was to draw the skeleton structure. So we have oxygen bound to oxygen. That is our skeleton structure. Step 2 is to fulfill the octet rule. So that means we want 8 electrons around each atom. So right now I only have 2 electrons around each oxygen. And remember that this bond right here, that is how oxygen is sharing electrons. So those 2 electrons belong to this oxygen, and they also belong to this oxygen. Okay, so now we have 2, 4, 6, 8, 2, 4, 6, 8. The next step is to check total valence electrons. Okay, so each oxygen atom contributes 6 electrons. So the total number of electrons that O2 has for bonding is 12. So we go to our structure, and right now we have 2, 4, 6, 8, 10, 12, 14. So we have too many electrons in our structure. If you have too many electrons in your structure, you're going to create a double bond. And in order to maintain the octet rule when you do that, you take 2 electrons from each of the elements that you're creating the double bond between. Okay, so I took 2 electrons from this oxygen, 2 electrons from this oxygen, I create a double bond. Now we have 2, 4, 6, 8, 10, 12. So that is the correct Lewis structure. Okay. In this compound, we have carbon present. Anytime carbon is present in a compound, it's going to be in the middle. It will always make 4 bonds if it can. So let's go through the steps. So carbon's there, so it's going to be in the center. And I'm going to surround that with the 2 hydrogens and a sulfur. Okay, so right now we have 2, 4, 6 around carbon. So I add another pair of electrons. Sulfur only has 2, 4, 6, 8. And now hydrogen actually only wants to have 2 electrons around it. So if we go back to the periodic table, hydrogen is in the first period. And in the first period, or the first energy level, we can only fit 2 electrons. So we will never ever have more than 2 electrons around hydrogen. Okay. So now we're going to check total valence electrons. And sulfur has 6, carbon has 4, and hydrogen has 1, but we have 2 hydrogen present. So we're going to add that up. So we should have a total of 12 electrons in our structure. Okay, so we go back to check and make sure that that's how many we have. This is the total number of electrons that are available for bonding. 2, 4, 6, 8, 10, 12, 14. So we have too many electrons in our structure. So what we're going to do is create a double bond. So the only place that we can put the double bond is between carbon and sulfur. And that's because you can't make a double bond between carbon and hydrogen. Hydrogen can only make 1 bond. So I'm going to take these 2 electrons here, these 2 electrons here, and create my double bond. Now I have 2, 4, 6, 8, 10, 12. So that is the correct structure